So we have 21 of Leetcode merged to sorted list. Now, before going to the problem, let's look at the constraint. We have the number of node from the range of 0 to 50. So the maximum number of node that we can have is 50. Now, as the number of node is very small, so we don't have to really worry about time complexity. Now, we also given two lists, list 1 and list 2. These are the linked list, and these are given in sorted and non-decreasing order. So we have to create a new list which will contain all the elements of the list 1 and list 2 in an sorted non-decreasing order. Now we are going to use a method called as toPointer. toPointer. First we are going to create a dummy node, right? A dummy node. Then we are going to iterate over the list 1 and list 2. Let's say first we are going to compare list 1 value and list 2 value. We see 1, so we'll write 1 to it. Move any of the pointer. Let's say we move the list 1 pointer to the next node. Then we compare 1 and 5. 1 is smaller, so we add 1 to our new list. Move the 1 pointer to the next element. Compare 2 and 5 similarly. 2 is smaller, we add the element. So any element that you find smaller, add it to it and move the pointer to the next node. So we add 2, move the pointer to the next node. Compare 2 and 5 again. 2 is smaller, we write 2, move it to the next node. We compare with 4 and 5. 4 is smaller, we write 4, move it to the next node. Compare 5 and 12. 5 is smaller, so we write 5, move the list 1 to the new node. Compare 9 and 12. 9 is smaller, so we write 9, move the list 1 to the new node, right? Now the list 1 has reached null, so we'll break out of the loop. We'll have a loop, do all these things and break out of the loop. Our question is not over, as our list 2 has another element that we haven't added. So what we will do is we'll add the left out element of the list 2, that is 12, right? Now the basic idea behind solving this question is that you iterate over list 1 and list 2. Once you hit a null, you iterate over the other linked list, copy all the rest left out element and put it into your new linked list. Now, whatever we did in this operation, we'll write it in the code. So the first thing that we did was we created a dummy node, right? So we'll create a dummy node. Let's say list node star dummy equal to, use the new keyword, list node. So this line creates the dummy node, and we are not going to touch this keyword and use another pointer as mover, so that we'll move over this new created linked list. So don't change this dummy node. At the end, we'll simply return dummy node dot next as the head of a linked list, right? So we'll create mover equals to dummy. So we'll have mover here. Now what we'll do is we'll run a loop. Now the condition of the loop will be if list 1 is not equal to null and list 2 is not equal to null, while list 1 and list 2 basically means list 1 is not equal to null and list 2 is not equal to null. We'll compare the values. If list 1 val is smaller than equal to list 2 val, if list 1 val is smaller than list 2 val, what we do is create a new node, write the value and move the list 1 pointer to the next. So create a new node, new list node, write the value list 1 val, store it into the mover's next pointer. This is mover and we'll have to store it into here. So this will be mover next pointer. So it will be mover next, and we will move the list 1 to the next node. So we move this list 1 into the next node. So we'll have list 1 equal to list 1 next. Now similarly for the else condition, we'll move the list 2. So we'll have mover next equal to new node. We create a new node, put the list 2 value as list 2 will be smaller, and move the list 2 node into the new node. So we'll have list 2 equal to list 2 next. Now there is another part that is left. we have to also move the mover, right? Once the mover was at the dummy, we create a new node. Now we have to move the mover to the next node. So at the end, we will write mover equals to mover dot next. Mover equals to mover next. Now there is one crucial condition that you have to keep in mind. Once let's say the list 1 pointer is at the null and list 2 pointer is at some node. Now once you reach any of these pointer to a null, the loop breaks. But you have to also take account of this left out 2 nodes and put it into new linked list, right? So what you do is you will have the mover to the last node and you point out that mover dot next will be list 2, will simply means that mover next will point to this element and will have a continuous element flow from the 12 to all the left out node, right? So what we will do is we'll check if list 1 is null or list 2 is null. So we'll write if list 1, we'll simply write if list 1, which means that list 1 is not null. If list 1 is not null, we'll point the mover next pointer to the list 1, and if list 2 is not null, we'll simply move the mover next pointer to the list 2. And at the end, what we will do is we had the dummy. Now the head of the, we have to return the head of the linked list. Now dummy is not the head of the linked list. The head of the linked list will be dummy dot next. So we will create a new head. Let's say list node new head as dummy next. Delete the dummy head. Delete the dummy node dummy and simply return the new head, right? We need to return the head. So this will be our complete code. Now we will talk about the time complexity and space complexity. For the space complexity, we are using an extra linked list which are storing all the elements of the list 1 and list 2. So it will be of the space complexity O n plus m. N being the number of node in list 1 and m being the number of node in list 2. The time complexity will also be the same, O of n plus m, as we are iterating once over list 1 and list 2. So the time complexity will be O n plus m and space complexity will be O n plus m.